Hi everybody, welcome to YGLF. My name is Dan, and today we'll be speaking about the challenges and the pitfalls of successfully implementing server-side rendering, also known as SSR, in your web project. Another way to put it is this is all the things I wish we knew when we implemented SSR at Wix as a solution for all the websites hosted on our platform. Indeed, to a great extent, this talk is the result of all the things that we encountered, all the problems that we had to overcome while implementing server-side rendering at Wix. So, Bruce already mentioned, my name is Dan Shappir. I've been with Wix for 5 years, more or less. My role at Wix is a performance tech lead, which indeed means that it's my responsibility to make sure that sites hosted on the Wix platform perform as quickly as possible, load quickly, and respond to user interaction. And indeed, there are over 100 million websites on our platform, which makes it a not insignificant portion of the web. So I really like to think that I can, help make the web a better place, at least in terms of performance. Okay then, so when you've been with high tech for as long as I've been, doing software for so many years, you see that technology is kind of like fashion, in the sense that what goes around comes around, and technologies that we used to have then kind of fade away and then kind of make a comeback. So when I started doing web development, essentially all dynamic web pages were rendered on the server side. Multi-page applications or MPAs. So you'd have technologies like PHP or JSP or ASP, all these three-letter acronyms that all end in P for some reason. And then along came single-page applications. And then suddenly we were doing the rendering on the client side. We had frameworks like Amber and Backbone and Angular. And the web page that was downloaded from the server actually became essentially like an empty page. It literally had nothing except maybe some, the title, and then reference to some JavaScript, and then it performed some AJAX operation, and all the DOM, all the HTML was essentially constructed on the client side. And it made it possible to create really dynamic experiences that we came to know as single-page applications or SPAs. But now it seems that we are kind of coming back to this approach of rendering at least the first page on the server side. And it's not exactly the same as rendering on the server, which is why it has this new name, SSR, server-side rendering. But there are a couple of important differences and distinctions between server-side rendering and rendering on the server and SSR. So one important difference is this whole concept with this terrible name called Isomorphic JavaScript, where we are essentially using the same code written in JavaScript or compiled into JavaScript, both on the server side and on the client side. So we might be running that code inside on the node server, on the server, and then also running that same code on the client. And the way that it works is that the server code essentially generates the HTML for that first page, delivers it to the client, and then when the client actually runs the same essential JavaScript code, what happens is this concept of called hydration, where thanks to technologies like virtual DOM, the client is able to, instead of rebuilding the HTML from scratch, effectively just hooks up event handlers into this already pre-existing HTML. So you get the look and feel, you could say, or the display from the server, and you get the functionality or interactivity from the same code running on the client. And then from that point on, as you navigate through additional pages on the client side, then those pages are essentially client-side rendered like you would do in any normal single-page application. Now, what are the benefits of this approach? So there are some benefits that I didn't mention, stuff having to do with things like it's a bit better for SEO, even though search engines are getting to be really good about being able to process client-side JavaScript as well, and it's also beneficial in case for some reason JavaScript is disabled in the browser, which can happen. But in most cases, the benefit actually has to do with performance. And there are several reasons why performance with SSR, especially as it relates to time to visible, can be significantly better than the performance with just client-side rendering. I won't go over this entire list because this is not the focus of the talk, but just to mention a few. So the first obvious one is the fact that you need to have fewer round trips in order to get the visible content. With client-side rendering, you download the HTML and then JavaScript and then you do some AJAX or something. So it's at least 2 or 3 round trips, whereas with server-side rendering, it's just that HTML that arrives. Another benefit might be that your servers can be just bigger and faster with more memory than the client device, especially if the client device, as is most common these days, is a mobile device and might be a really low-end phone. And other reasons as well. Okay then, what's the impact? So at Wix, when we actually implemented server-side rendering for all the websites hosted on the Wix platform, the performance gain was really significant. In fact, of all the actions that we took, everything that we've done in order to improve performance over the past 4 or 5 years, this has been the most significant change. As you can see, it improved performance by something like 60%. Or another way to look at it is that what used to be the performance that was the median is now it's what we get with the 90th percentile. And the performance that previously only the 10% of users with the fastest connections and devices used to get, now it's what half our users are getting. So the performance improvement was indeed dramatic, and we were very, very pleased with that. But it turned out that it wasn't really that easy. Oh yeah, but before that, one more thing. Another really useful thing about SSR is that now it's really supported by essentially all the main frameworks. So whether you're using React was kind of the lead, kind of innovated that, but right now it's supported in Vue, it's supported in Angular, it's even supported in Ember, and I'm sure that it's supported in other frameworks as well. So whatever framework you're using, you're basically kind of getting this functionality. So in other words, what's not to like? You've got support built in the framework, the performance gain will be huge. I mean, you know, we should all be doing SSR. Well, it turns out that it was definitely not that easy. In fact, when I joined Wix 5 years ago, one of the first things, we were already then looking at SSR, and it only took us over 3 years to actually succeed. And like this boxer that has 2 black eyes, it actually took us 2 failed attempts before we were actually finally able to succeed with the 3rd try. And even that successful implementation took us more time, requiring more resources than initially anticipated. When I'm thinking about the reasons of why SSR turned out to be such a challenge to implement, I like to group the challenges into 2 main categories. The first one is technical challenges. If all of you are, well, if some of you are familiar with the excellent article, No Silver Bullet, which I highly recommend just going out there and Googling, or you can find the link here in my presentation. This is the concept that is often known as accidental complexity. It's the fact that there are challenges or problems or limitations that we can overcome, but it requires work and it requires using the best and the most appropriate tools. Then there are also the inherent challenges. These are problems that are kind of built into the problem domain that you can't really eliminate. They're there. You can try to mitigate them, reduce their impact, but it's a challenge that you have to face. And this is often known as essential complexity in the context of that article that I mentioned. So let's start with the technical challenges. And I'll just go through a couple of them, not all of them, the main ones. So as I was saying, you're probably going to be implementing SSR using some sort of a framework. And I'm sure all of you, or most of you, are already using a framework in your web project, regardless of whether you're using SSR or not. And it would seem that if you're using a framework, then you shouldn't be accessing the browser DOM directly. But the reality is that we all know that we all do it. Even though we're using some sort of a framework, somewhere in our code, there's a window dot something. And if it's not direct use of the DOM, then it's probably something like jQuery. And there are legitimate reasons for that. First of all, obviously not all the browser DOM API is exposed by most frameworks. So if I want to use some functionality that's not really part of the framework, I need to access the DOM. Also, sometimes, even with the best frameworks, it just makes sense to circumvent the framework in certain cases, special cases, that we all seem to encounter in our applications. And finally, some of us are just lazy, and you say, okay, we'll just do an inner HTML or something, and it just works. And this is the problem with server-side rendering, is that obviously, while you can definitely use the browser DOM in the browser, you can't use the browser DOM on the server, because it just doesn't exist. If you try to do window dot something on the server, in Node, it will explode. You can put something like JS DOM, but obviously that's not such a good idea, because anything you do will not actually get reflected down to the client. So you really want to not use the browser DOM in your code when you're doing SSR. So what can you do about it? Well, the obvious thing is to basically eliminate it. Go over your code, find references to window.anything, and just pull them out. But the reality is, as I said before, is that in some cases it's unavoidable. And in those cases, you probably what you will need to do is you will need to safeguard that access using something like type of window different than from undefined. You'll probably want to wrap all those DOM accesses in some sort of a helper library that does these tests and checks to make sure that your application doesn't explode when running on the server. Let's consider another challenge. This one is kind of more insidious, because it's not in this, because the previous one was kind of obvious. You know you don't have a DOM on the server. This one is more tricky, and that's the concept of the JavaScript context. When we're running JavaScript in the browser creates essentially a new instance whenever a new page is loaded. And when you navigate away or close the tab, the browser basically does a cleanup for you. Even if you just do an F5 to reload the page, that's a whole new clean context. And what do I mean by clean? It means that all the objects that you've allocated in memory, they're cleaned away, they're removed. And if you've modified various globals on the Windows object, those are gone. So information from one session doesn't leak or make its way into another session. But that's not the case when you're running on the server side, because, well, obviously you could do something like shutting down the node server after each session and then starting it up again. PHP kind of did something similar, or does something similar between sessions. But in Node, that's not the way you work. In Node, you basically want to reuse the same Node session instance between different sessions coming in over the network. And that means that the same global variables, for example, will continue to exist. So if you have, let's say, a global variable that contains some sort of a mutable value that the session can actually write into that global variable, then that value will actually, the modified value, will persist into the next session. And obviously, this can introduce all sorts of security concerns, privacy concerns, or just plain old bugs, because you assume, let's say, that a certain counter is initialized to 0, but you end up with whatever it was at the end of the previous session. And this could happen, certainly, when you're running multiple sessions at the same time, but it can even happen when you're running multiple sessions sequentially within the same node session. So it means that global variables, in fact, and it's not just global as, you know, variables defined in the global scope. It might be properties on the global object. It might be module level global variables. All these, if they are mutable, are not something that you can really use inside a server-side rendering solution. So what can you do about it? Well, an obvious solution is to basically just not allow mutable globals. But that's obviously much easier said than done, because at the end of the day, our applications tend to have state, and state does change over time. So one approach that we found to be fairly useful is to basically replace what would be simple mutable globals with weak maps that we would key based on a unique session ID. And the great thing about weak map in this context is that once that session is done, then the garbage collector is actually free to collect all that memory, and you don't have to go explicitly through all these globals and release the memory. You know, let me ask you a question. It's kind of a rhetorical question. If your application, say, leaks 10 kilobytes per second, is that a lot? Is that a little? Well, is it a problem? Is it something that you have to solve? Well, it turns out that for the client side, you could probably ignore that, because if a session, let's say, lasts around 5 minutes, in your case, then you've talked about a leak that accumulates to around 3 megabytes, which is, well, at the end of the day, something that we can probably live with. But in the server side, if a server is running continuously for 24 hours, that adds up to almost 1 gigabyte of memory. And that's not something that we can live with. So that ends up in a scenario where, you know, you kind of have to restart your node servers every several hours because they are just running out of memory and potentially blowing up, or performance really degrades. So problems like that used to be non-issues in client side become real issues in the server side. And this is kind of a mental change, because with client side, you know, if you deploy your application and it seems to be running well after the deployment in production, and you have enough users that actually play with it, and you see no problem in, let's say, an hour, then you know you're probably safe. But with server-side rendering, you're getting into this DevOps world where you can get a phone call on a Friday night at 3 a.m. that the server is blown up because it's leaking resources. So that's definitely something to watch out for. So in coming to grips with all these technical challenges, we really had to consider the processes that we use and the tools that we use. And some of the tools are one of the main tools, one of the most significant differences that made the difference between the successful SSR project and the ones that failed, was that we went through a test-first approach. In our case, we had a client-side rendering solution. We wrote a ton of tests that passed for that client-side rendering solution, and then we made sure that when we went with SSR, whatever change we made, all these tests continue to pass. So if there's one key takeaway from here, is write a ton of tests and just make sure that they keep on passing. Turns out that ESLint was a very powerful tool or utility in our belt for successfully implementing server-side rendering. For those of you who are not familiar with it, ESLint is a linter tool that verifies that you're coding your JavaScript according to particular standards. And what's really cool about ESLint is that it's extensible, so you can add your own rules. In our case, for example, we added rules that checked for unguarded DOM access, or we added rules that checked for the use of mutable globals. and actually failed the build when there was such code being pushed into production. This made it sure that once we fixed the code in order to work successfully, developers could not accidentally check in code that would cause problem in an SSR environment. For memory leaks, it turns out that we basically just had to learn more and understand the various Node.js tools that are out there, stuff like Node Inspector and the various libraries and tools that you can use. There's no getting around that. If you're going to be running your software on Node, you need to have people with Node expertise on your team. Okay then, so all of these problems were technical challenges. Now let's consider some of the problems that are inherent to the very approach of server-side rendering. So with client-side rendering, the time to visible and the time to interactive are essentially one and the same. That is, you get the blank HTML page, you run the JavaScript code, it generates the HTML, the DOM, and it's instantly visible and interactive, meaning that if there's a button, you can click the button. If there's a menu, you can select a menu item and so forth. That's not the case with SSR. With SSR, these two become distinct. SSR really improves the time to visible because you get that HTML with all the visible elements really, really quickly. But it turns out that time to interactivity at best stays the same. In fact, from what we've seen, in most cases, you actually even experience some degradation. So it creates this scenario where you have a visible user interface, but it's either non-interactive or at best partially interactive. And I recently saw a presentation in which they mentioned that Akamai did a research that shows that if time to interactivity is more than 30% longer than the time to visible, that induces rage clicking, which means that if there are buttons, people actually start going like tat, 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 because they're annoyed that nothing responds to their interaction. In other words, what you get here is not so much a performance issue anymore. It's actually, you could consider it to be a bug in the software. You have a user interface that the user is trying to interact with, and it doesn't actually work. Now, this is an inherent problem because it's just a fact of life. This is what SSR does. It improves visibility. It doesn't improve interactivity. So what can we do about it? We can try to mitigate it. That is, reduce the impact of it. So one approach, for example, let's say you're using React in order to render your user interface. You don't have to put all your React rendering under one node. You can actually break it up and do rendering under multiple routes. So, for example, you could split your page so that all the part that's above the fold, maybe going a little bit below the fold, is rendered with one route, and the rest is rendered with another. And then you can do like this sort of hydration in parts. So you first hydrate the upper part, and then you hydrate the rest. And you can, and with React now, also hydration can be interruptible. So if then somebody tries to interact with a part that's above the fold, that'll be already responsive while you're still hydrating whatever exists below the fold. But again, this does not eliminate the problem, it only mitigates it, because, for example, if somebody scrolls down or even just loads the page when they already scroll down, they will try to interact with components that are at the bottom, and they will be frustrated. Another benefit is that in most cases, people don't start clicking right away, because people tend to look at the page before they start interacting with it. But still, again, if your interactivity takes too long, then you definitely have a problem. Another intrinsic problem is the problem of diverges. A diverge is what happens when the HTML that's generated on the server side is different, either partially or completely, from the HTML that is going to be generated on the client side. So it turns out that the hydration process, instead of just hooking in the interactivity, actually has to replace some of the stuff that was previously rendered on the server. Now, there are actually two reasons why this might happen. One is, let's call it unjustified diverges. You can think about them as bugs. For some reason, the code running on the server is generating slightly different HTML than the code that's running on the client. Maybe it's a timing thing, maybe it's the version of some library you're using, maybe it's just the fact that it's a node environment rather than the particular browser that is being used. The way to work around that is we basically built in tests that do a comparison of the HTML that is received from the server with the HTML that exists on the client after the client finishes the hydration process. If the two aren't sufficiently equivalent, then that is flagged as a bug and it breaks the build. So that's the way to deal with unjustified diverges. But there are also justified diverges. Think, for example, that your page has, let's say, the time and date at the top left-hand corner of the screen, and your server happens to be in a different time zone than your client. Then time will obviously be different. Maybe even the date will be different. But even if that doesn't happen, time will pretty much certainly be different when it's rendered on the client and on the server. So that's a diverge that's not caused by so much as a coding problem. It's basically an unavoidable result of the design of your web page. So in that case, what can you do? The best way is to basically try to design your page in such a way that these kind of diverges don't occur. And if they're unavoidable, then what we've seen is that a better user experience is to generally put in some sort of a placeholder rather than putting in a wrong value and then replacing it with the right value after a bit. It's kind of disconcerting to see something like a flash all of a sudden with a different value. So it could be like a spinner maybe, or even a blank area with no content, and that content is then later filled in when the client does its own work. So, to summarize what we've talked about so far, as we've seen, SSR can achieve a dramatic improvement in the performance that your users experience when they're visiting your website. I think we can all agree that a 60% improvement in time to visible is very, very significant. But on the other hand, it does have its issues. It's not a trivial undertaking. It's not something that you can say, okay, I'm using React, I'm using Vue, I'll just fire up a couple of node servers, and I'm done. As I said before, test, test, and test again. Again, if there's one takeaway that you should take back from this talk, testing is always a good approach. We will have talks later about testing in YGLF, but in this context, if you want to have a successful SSR project, that's what made the difference for us, that it was a test-first approach at building this project. Second, make sure to allocate sufficient resources and time for it. Again, another difference between our successful projects and the ones that failed is the fact that after having failed, we looked at why we failed and say, hey, we didn't allocate enough people, we didn't give them enough time. Let's do it right to actually set up a fairly large team that actually worked specifically on this project, and we gave them all the time that they needed, and they actually needed more time than was initially given to them. And remember that it's an inherent problem of this approach that time to visible is going to be smaller than your time to interactive, and you're going to have to face up to that and style your project and implement your project in such a way that visitors to your site don't consider it to be a bug because your site simply is not responsive to their interactions. And essentially, that's that. Thank you very much.